Today we will study the topic of locus. The weightage of this topic is about 3 to 4 marks. One question in section B normally. But since it is an easy topic, it could also come in section A. But most of the times if you see, it is put in section B. You can get one question based on locus and one question based on construction of circles. Actually, these two topics are interconnected. So sometimes you will get one question of 4 to maybe even 5 marks blending both the topics, locus and construction of circles. They are to a large extent interconnected. However, in this topic we will focus on locus. Let us understand what is the meaning of the word locus. Locus means the path traced by a moving point, satisfying certain geometrical conditions imposed upon it right from beginning to the end. So certain conditions are imposed on the point which is free to move anywhere on the plane of the board. And whatever path it traces, that is known as locus. Let us take some example. This is a line. Say we call it L1. This is a point P, which is free to move anywhere in this whiteboard. Point P is free to move anywhere in this whiteboard, but some condition we are going to impose on it. This point P should always be at a fixed distance from this line L1, at a fixed distance. So right now, this much is the distance. Suppose the distance is 3 centimeter. Now can I take the point here? No. If I take this point P here, P is a moving point. What are we doing? We are trying to find the locus of this point P, path traced by this point P. But there is some condition imposed on it. What is that condition? It should be at a distance of say 3 centimeter always from the line L1. So one possible position of this point P is here. We can have P here also in such a way that this distance also should be 3. Now in distance means perpendicular distance. But P can be here also. As long as the distance is 3, no problem. Now we have got 3 good points. In my way of teaching, good points, meaning of good points is which are obeying the conditions given. So this point P is 3 centimeter away from this line L1, perpendicular distance. But it is not necessary P has to be here. P can be here also. Again 3 centimeter distance. Again you take point P here in such a way that this distance should be 3. Even this point P what we have taken, you take it in such a way that this distance, the perpendicular distance is 3. So now try to join these points. Try to join these points. What do we get? We get another line, a straight line which is parallel to the original line. So the locus of this point P under the given conditions is nothing but a straight line parallel to the original line. Same thing can happen on this side also, because 3 centimeter can come on this side also, the perpendicular distance. Not necessarily on the top side, it can come on the bottom side also. So which is the path traced? This. This is the path traced. Now path traced is not always a straight line. It can also be a curve. So now what conclusion we come 2. Locus of a point is nothing but a path traced by the moving point, satisfying certain conditions imposed upon it. Right from the beginning to the end, some conditions are imposed upon it. So the word locus may sound scary, but it is very simple. However, note that this concept which I have explained is no longer in the new syllabus. But this was a good example to take for understanding. Okay. Now let us see which concepts we are having in the topic of locus. We have only 3 concepts in the topic of locus. We will study them one by one. Consider segment AB. We'll perform an experiment and then come to a conclusion. I need one point, say P, which is equidistant from A and B. So A and B are what? They are 2 fixed points. A and B are 2 fixed points. I need one point which is equidistant from A and B. So I can take P like this. I can take P to be the midpoint of A and B. So naturally PA and PB will be equal. Now just ponder over, is this the only possibility? Or can P be somewhere else? However, satisfying the condition that P should always be equidistant from A and B. So what do we do? From A, we can cut an arc, say 3 centimeter. We can cut an arc of 3 centimeter. And from B, again cut an arc of 3 centimeter. Why? Because we want a point which is equidistant from A and B. जितना point P A से दूर है, उतना ही B से दूर होना चाहिए. So we'll have to cut 3 centimeter arc from A, and from B also you cut 3 centimeter arc. This is also a point. This is also okay. This position is also fine because PA and PB will be equal. Why? We have cut the arcs that way. Now from A, cut an arc of say 5 centimeter. And from B, again cut an arc of 5 centimeter. So this will be the point P. Point P can be here also because PA and PB will still be equal. Kindly note, A and B are 2 fixed points. You cannot find the locus of a fixed point. Locus will always be of a point which is moving. So P can be here, it can be the midpoint. So PA and PB are equal. P can also be here because again I will get PA and PB as equal, say 3 centimeter. We have cut the arcs that way. P can be here also. So there are several possible positions of P which will satisfy the condition PA is equaling PB. In other words, P is equidistant from A and B. Now we have obtained 3 such points which are satisfying our condition. Now the time has come to join these points. Why? Because when I join these points, we will get an idea of the path. So this is the path traced. This is the path traced. Now we can assign some special name to it. Use your power of observation. This line is passing through P and P is the midpoint. So naturally this will be the bisector. However, look at this angle. Take your protractor and measure this angle. You will realize that this angle is 90 degrees. If you perform the experiment correctly and accurately, you will realize that this angle is now 90 degrees. So this special path which is traced out can be called as the perpendicular bisector. It does two jobs. 90 भी बनाता है and it also bisects, is passing through the midpoint. So it is perpendicular bisector. So this is our first concept in locus, which we say the locus of a point means the path traced by the point. So again, locus of a point equidistant from two fixed points is the perpendicular bisector. So I will write it here. The locus of a point equidistant from two fixed points is the perpendicular bisector. So note that A and B are fixed points and P is the moving point. And what condition was imposed on P? It can move anywhere on this whiteboard as long as PA and PB are equal. So we performed the experiment and we came to this conclusion. Now these concepts can also be proved, but we are not having the proof of it. So from the experiment we have drawn the conclusion and we understand this. Before we go on to concept 2, it is nice to note that the converse is also true. Any point on the perpendicular bisector will always be equidistant from two fixed points. Okay, so reverse is also true. So if somebody tells you this is the perpendicular bisector, I am taking any point on it, will it be equidistant? Yes. Concept 2. Let us have two intersecting lines, L1, L2. There is one point P which has to be equidistant from L1 and L2. Distance of a point from the line. So if a point is, say, here, if this is, say, 1 centimeter, then this also should be 1. This is the condition which is imposed on this point P. Now what is our objective? We are trying to find the locus of the point P. P is a moving point. L1 and L2 are the lines which are fixed. Now P is a moving point. It is free to move anywhere on this whiteboard. But one condition is imposed on it. At any given point of time, it should be equidistant from L1 and L2. So distance of a point from a line will naturally be the perpendicular distance. Now if I take a point here, say this is 2 centimeter and this also should be then 2. So we take our point P that way. We can take point P here also. So this distance and this distance should be same. Having obtained 3 such good points, we try to join them to get an idea of the path traced. Now observe and you measure these two angles. They will turn out to be equal, indicating that this path traced is nothing but the angle bisector. So this is our path traced, and a special name what can be given to it is angle bisector. Same experiment can be done on this side also, which I am not doing it now, but the same concept holds true from this side. because you look from this side or this side, these are still lines L1 and L2. So the concept says the locus of a point equidistant from two intersecting lines. The locus of a point means the path traced by the moving point from two intersecting lines is nothing but the angle bisector. The locus of a point equidistant from two intersecting lines is the angle bisector. So this is concept 2 of locus. Conversely, any point on the angle bisector, any point, not necessarily these 3 points, any point on the angle bisector will always be equidistant from two intersecting lines. So this was our second concept of locus. It has been written down. Do not confuse between concept 1 and concept 2. Concept 1 was what? Locus of a point equidistant from two fixed points. What was it? Perpendicular bisector. Second concept, locus of a point equidistant from two intersecting lines is the angle bisector. So this takes care of second concept. Third concept of locus. A is a fixed point. We wish to find the locus of point P. Now what is the condition imposed on point P? P is free to move anywhere on this whiteboard, but we are going to impose some condition on it. It should always be at the same distance from the fixed point A. Wherever, let P be anywhere, wherever it likes, but it should be at the same distance from point A at any given point of time. So say from this I take 3 centimeter. Take a scale 3 centimeter. P can be here. But P is free point. Somebody takes a scale from A, you take a scale like this in this direction. Won't we get 3 centimeter? So we'll get here. We can actually perform this experiment and see. Again from A, take a scale in this direction. So P will be here. From A, 3 centimeter can go like this also. From A, 3 centimeter can come here also. From A, 3 centimeter can come here. From A, 3 centimeter can go here. Right? So AP is 3, AP is 3, AP is 3. Now we have got so many such good points which are satisfying the condition. Now what should we do? We should join them to get an idea of the path traced. As mentioned before, the path traced may not always be a straight line. It can be a curve. Here one more point can come. 3 centimeter, 3 centimeter. So if you judge it, it will be a circle of radius 3 centimeter. So this is concept 3 of locus. Locus of a point equidistant from a fixed point. From a fixed point is the circle. What was first concept? Equidistant from two fixed points, perpendicular bisector. Second concept, equidistant from two intersecting lines, angle bisector. Third concept, equidistant from a fixed point. Here A is a fixed point. It will be a circle. So A is a fixed point, P is a moving point whose locus we are trying to find. the locus of a point equidistant from a fixed point is a circle. So now we have finished 3 concepts of locus. We have only these 3 concepts in our syllabus, and soon we will see few typical construction problems based on fusion of these concepts. Question 1. Construct triangle ABC in which BC is 6.5, ABC is 60 degrees, AB is 5 centimeter, and then certain conditions are given. Now, rough figure does not carry any marks as such in the board exam, but it is very essential to draw the rough figure to get an idea as to how the final figure will look like, how the diagram will look like, and what should be our course of action. So we will just try to get a sketch how we go about this. BC is 6.5, rough diagram. Okay, BC is 6.5, ABC is 60 degrees, AB is 5. So we have drawn the triangle. Construct the locus. Okay, this is fine. This we can do it directly also, 3.5 centimeters. We got an idea as to how to get the triangle first. Okay. Remember, always start construction sums on a fresh page and start from the center of the page. The reason is we do not know how big the construction is and how will the final construction look like. If you start towards the end of the page, at times it will not fit in, and then you will panic, cancel, and there is heavy loss of time. So remember, construction sum, any construction sum, always start on a fresh page and from the center of the page so that we know it is going to fit in properly. Steps of constructions are not to be written, not required. First we will draw BC as 6.5 centimeter with the help of a scale. As this is an opening segment, we can draw directly 6.5. Otherwise, some books say just draw of any length, cut 6.5. That is not really required. Opening segment you can take directly on a scale. Angle ABC is 60 degrees. Here it is presumed that you are well aware how to construct angles. This was covered in 6th and 7th standard, 60 degree, 120 degree and all. Any angle which is a multiple of 15 degrees can be drawn with the help of a compass. Any angle which is not a multiple of 15 degrees, like say for example 100 degrees, 103 degrees, if such odd angles come, then you can use a protractor. But otherwise use a compass to draw all angles which are multiples of 15. Now here angle ABC is 60, very easy. With B as the center, compass in your hand. This is arc of 60 and 120. So we have drawn the 60 degree angle. AB is 5. Now we cannot take a scale and just draw. We will have to cut an arc. So AB is 5. So say this is A, 5 centimeter. Join. So this becomes our triangle ABC, which will fetch you 1 mark. Construct the locus of a point at a distance of 3.5 centimeter from A. Now you have to understand which concept to apply, 1, 2 or 3. So construct the locus of a point at a distance of 3.5 centimeter from A. Now 3.5 centimeter from A means it can go 3.5 here, 3.5 here, anywhere it can go, isn't it? So it is concept 3 what has been taught to you. Locus of a point equidistant from a fixed point. So take 3.5 on a compass. So what the locus will be? It will be a circle. So with A as the center, take 3.5 and trace out a circle. Now next condition, construct the locus of points equidistant from AC and BC. This is AC, this is BC. So they are two intersecting lines. The AC and BC, two intersecting lines. Recognize the concept. Is it concept 1? From two fixed points? No, it is a second concept. Locus of a point equidistant from two intersecting lines. What will it be? Angle bisector. So it is AC and BC. So angle is here. So we will have to draw angle bisector. How to draw? With a compass. Put the pointed edge of the compass on C. Draw an arc of any convenient radius. Then put the pointed edge here. Radius more than half. Draw the arc. And again with this as the center, same previous radius, cut the arc. So this will become the angle bisector. This takes care of this condition. Now mark 2 points X and Y which are at a distance of 3.5 centimeter from A and also equidistant from AC and BC. Now if you notice, this fourth subpart is based on second and third. We did second separately, we drew a circle. For third subpart we drew an angle bisector. Now what are we being asked? Mark 2 points X and Y which are at a distance of 3.5 centimeter from A. That means such points should lie anywhere on the circumference of the circle, because this has to take care of the second condition. So circumference of circle, there are so many points, but they have asked us to mark 2 points which are at a distance of 3.5 from A, and next condition is also imposed upon it, also equidistant from AC and BC. That means those points should also lie on the angle bisector. So not only they should lie on the circumference of the circle, but they should also lie on the angle bisector. Now which are two such points? This point X, because this point lies on the angle bisector and this point also lies on the circumference. So it will satisfy both the conditions. Even this point Y will satisfy that condition, because Y is lying on the circumference of the circle and Y is also lying on the angle bisector. So marking of these 2 points is essential. Otherwise, how will the examiner understand? You cannot say, okay, these are the 2 points. You have to mark it. No? Measure XY. Now naturally you will take a scale, measure it, and you'll have to write XY equal to. Now this turns out to be 8.2 centimeter if you actually draw. An error margin of 1 millimeter is definitely permitted. So a standard 4 marks question, 1 mark for the triangle, 1 mark for the circumference of the circle, 1 mark for the angle bisector, and also marking the 2 points X and Y, and finally for recording XY. So maybe circle could fetch you 1 mark, triangle would fetch you 1 mark, angle bisector would fetch you 1 mark, and for finally identifying X and Y and measuring the distance between those 2 points and writing will fetch 1 mark. So are you comfortable with this? So we realize that locus problems are fusion. It could be fusion of concept 1 and 2 or 2 and 3 or 1 and 3 or maybe all 3 together. Done with this. Question 2. Draw 2 intersecting lines inclined at an angle of 60 degrees. Locate all the point or points which are equidistant from the 2 lines and also at 4 centimeter from the point of intersection of the 2 lines. So first we just draw a line with a scale, of course. Take any random point here. Draw 60-degree angle, which you are aware how to draw 60-degree angle. So this line is say L1, this line is L2, this angle is 60 degrees. Locate all the points which are equidistant from these two lines. Which concept? 1, 2 or 3? Equidistant from two intersecting lines. Concept number 2. That will be angle bisector. So I will have to draw angle bisector of this 60-degree angle, which you already know how to draw now. It was explained in the previous sum. But we will also have to draw angle bisector of this 120 degrees, because you can view the line from this side, somebody can view the lines from this side. No harm, they are still the lines L1 and L2. So this was the main trick in the sum. One more angle bisector will come. Now this is 0 degrees, this is 60, this is 120, this is 180. So actually if you go to see, this arc already acts as an angle bisector, because this is an arc of 120 degrees. This is 0, 60, 120, 80. So this is already drawn before only. So we need not bisect the angle. However, if you don't realize this, it's fine. You can again just draw any arc of convenient radius and bisect this 120 degree angle. So we draw here, because this arc automatically acts as an angle bisector. So we have drawn two angle bisectors, but one more condition is imposed. 4 centimeter from the point of intersection. So this is a point of intersection. From here 4 centimeters. So this is a fixed point. From here 4 centimeter can go anywhere. So what will that be? Circle. So we will trace out a circle with a compass. Pointed edge here and radius 4 centimeters. Now we have to locate the points which satisfy both the conditions. Which are these conditions? They should be equidistant from the two intersecting lines. That means they should lie on the angle bisector. At the same time, they should lie on the circumference of the circle, because they have said 4 centimeter away from this fixed point. So now lines I have drawn arrows so that you don't get confused between the original lines and the angle bisector. So this was my first angle bisector. So this will be the point, say P. It is lying on the angle bisector. Also it is lying on the circumference of the circle. Again on this side also. Then this was my second angle bisector. So here. So P, Q, R and S are 4 such required points. We will have to write that statement better. P, Q, R and S are 4 such required points. So now we have done with this. Naturally, construction, you already know it will come in pencil. Okay, and by the use of proper geometry box, instruments, compass, scale and all, and in the end have they asked to measure and record any distance? No. Okay, so this completes the sum. Question 3 and the final sum of this topic. Construct triangle ABP such that AB is 5, BP is 3 and ABP is 60 degrees. Complete the rhombus ABCD such that P is equidistant from AB and BC, and then locate the point Q on BP such that QA is equaling BQ. Interesting question. I think in 2007, a similar question had come. It was complete the rectangle ABCD such that. So instead of taking that question, I have taken a modified version of it. Now AB is 5, BP is 3 and angle ABP is 60. So angle B is 60. So we'll try to keep B down for the sake of convenience. So we would draw AB as 5 centimeters. It is an opening segment, so we can directly draw 5 with the help of a scale. Angle ABP is 60 degrees. Now with B as the center, any convenient radius, we draw this semicircle with the same settings unchanged, and with this as the center, we cut 2 arcs. So we will get 60 degree and 120 degree. We have just drawn that and kept. Okay, whether it will be useful or not, we don't know. Okay, but let's first complete the triangle. Now BP is 3, so AB is 5, and this is 60 degrees, and BP is 3. So this would, now this you will have to cut an arc of 3 with the pointed edge here, cut an arc of 3 centimeter. So that would locate our point P. Join. Make it a little more clear. So this becomes triangle ABP. 1 mark, you will get it here. Now this is an interesting sum. Complete the rhombus ABCD such that P is equidistant. Now P is already located. P is equidistant from AB and BC. Reverse thinking. Try to visualize. P is equidistant from AB and BC. Where it is BC? Where is BC? From AB and BC. Now in rhombus what happens? All 4 sides are equal. Here it is told to you that this point P is equidistant from AB and BC. So C could be somewhere here, because when I am completing the rhombus ABCD, this is A, this is B, so naturally C would be somewhere here and then D, and the rhombus would be completed. So we will have to draw 120 degrees now. Why? The reason is, if P has to be equidistant from AB and BC, then P has to lie on the angle bisector, equidistant from AB and BC. AB and BC are not points. AB and BC are sides which are intersecting, AB and BC. That means this P should lie on the angle bisector. So reverse thinking, BP is already drawn, that, and this is how much? Angle 60 degree. So we will have to join this, because this was the 120 degree arc. So we will have to draw 120 degrees so that this 60 degree acts as the angle bisector. So it's reverse thinking. So we have drawn this. Now question arises, where would be point C? So this P has to lie on the angle bisector. So now if I draw this line at 120 degree, then BP acts as the angle bisector, and P is equidistant from AB and BC. So P should lie on the angle bisector, which was already drawn before. So to make BP as the angle bisector, we had to draw 120 degree angle. No? Reverse logic now. Okay, now how to locate C? In rhombus all 4 sides are equal. AB is already 5. Easy. So with B as the center, cut an arc of radius 5 centimeter. So this would be C. Now we have to just locate D. So look like this. So this is, say, A, B, C, D. This is 5. This is also 5. In rhombus all 4 sides are equal. Now how do, so A is there, B is there, C is there, and what is ABCD? It is a rhombus. So we just have to locate our point D. But how to locate point D? This point D will be 5 centimeter from A. Do you agree? All 4 sides of a rhombus are equal. The same point D will also be 5 centimeter from C. So now what we do, with C as the center, we draw an arc of 5 centimeter anywhere, like a sufficiently longer arc, and with A as our center, we cut the arc. With A as a center, we cut the arc and then join, and that will become our rhombus. So ABCD will become our rhombus. So reverse come, instead of rhombus being drawn before, we draw part of it and then we are asked to complete the rhombus. Comfortable with this? So this is done. However, we need to understand that one more part is still remaining. Locate the point Q. Locate the point. Of course, now here I would like to tell you that this BP will act as the diagonal. So it will pass through here, since I have drawn the arc roughly, it is not passing, otherwise this will pass through this. This will act as the diagonal. Because if this is 120 and this is 60, then diagonal of a rhombus bisects the vertex angle. Okay, locate the point Q on BP such that QA is equaling BQ. Now one may wonder which concept is this or how it is. This has been put in a disguised form. Try to decode it. QA is equaling BQ. So if this is QA is equaling BQ, so can't we have the diagram like this? Isn't it? QA equaling QB. Now you call QB or you call BQ. What difference it makes? It refers to the same segment. So they have given Q has to be a point in such a way that QA and BQ should be equal. So if I draw a rough sketch, it helps me to imagine what actually will happen. So QA, okay, is equaling QB. So this condition I have taken care of. Now can't I say that Q is equidistant from A and B? Because if QA is equaling QB, that means Q is equidistant from A and B. Now are you able to get it? Which concept of locus? Concept number 1. Locus of a point equidistant from two fixed points will be the perpendicular bisector. So here the framing is such that you should be able to judge that we are supposed to draw the perpendicular bisector of AB. Right? Because QA is equaling QB. So if a point is equidistant from two fixed points, concept number 1, it will always lie on the perpendicular bisector of here. Now in this case it will be AB. So AB is already there. You just draw the perpendicular bisector of AB. From A, radius more than half, take an arc. From B, same radius, cut. Draw the perpendicular bisector of AB. So any point on this will be equidistant from A and B. But what they want? Locate the point Q on BP. So this is our segment BP and this is the perpendicular bisector. So this is BP, it is extending. This is the perpendicular bisector which we just drew. So you know the perpendicular bisector with A as a center, draw the arcs up and down. Radius more than half, with B as a center, same previous settings, cut the arcs and draw the perpendicular bisector. And where it is meeting BP? Here. Okay. So this will be the point Q which will be equidistant from A and B. Now that way any point on the perpendicular bisector would be equidistant from A and B. But since they said it should be on BP, we have to see where it is meeting. So this will be our point Q. So this was a very good sum. Okay, it has not yet come. It could come anytime in the future in the board. So we are done with this. Thank you.